Hi everyone, welcome to Symphony TechTalk. And my name is Bogdan Mikhailishin and I'm an internal communications specialist here at Symphony Solutions. We are a cloud and AI-driven IT company with headquarters in the Netherlands with a remote presence in over 20 countries. But now we are streaming live from our Lviv office in Ukraine. And today we are talking about how to get ahead in tech with architectural thinking. We're thrilled to have the legend as our guest and cannot wait to hear all about his experiences and insights. So, our tech rockstar is the mastermind behind the developer to architect concept. His books, for example, Fundamentals of Software Architecture and Software Architecture, the Hard Part, are just classics. He has shaped the careers of hundreds of architects all around the globe. And today he's here at Symphony TechTalk. So we are so ready to learn from the best. Please welcome Mr. Mark Richards. How you doing,
Well,
Mark?
thank you so much for that intro. I'm not sure what to say.
We
Thank
are
you.
happy to have
Um,
you. We're glad that you've agreed to talk to speak for us, and we are so excited to actually listen to you talk and to ask questions because we have a lot. So
oh yes.
that is for all of us watching on YouTube. I would kindly ask you to let us know where exactly are you watching us from, which country, which city, which part of the world. What do you do? What is the area of your interest? Are you an architect? Are you a software engineer? Are you someone else? And then please address your questions. We will have 45 minutes of the talk of our speaker and then 15 minutes for the questions. So be ready and have your questions ready in the comment section here on YouTube. And right now, I don't want to waste another minute of time, and I would yield this virtual stage for Mr. Mark Richards. So, Mark, the stage is yours.
All right. And again, thank you so much for having me on the Symphony Solutions Tech Talk. This happens to be one of my, favorite topics. I have a lot of favorite topics, but this one in particular, architectural thinking, is one of my favorites because it applies to every level of technologist. Whether you are a developer, a tech lead,
To
a
be
junior
one of
architect,
my
senior architect, all of this does apply. So that's why I love this context. I also love the backdrop. I did actually start my career back in the very early 80s as an astronomer. I worked at Braeside Observatory in Arizona in the United States. And so looking at this backdrop is bringing back a lot of fond memories of my astronomy days. So what I'm going to do is I'm going to share my screen so that I can actually start showing you about what architectural thinking is really all about. Before I start, one other very exciting thing this month, we actually just released our third book about software architecture, and that is O'Reilly's Head First Software Architecture. And this just, as a matter of fact, came out, I believe, about a week and a half ago. This was 2 years in the making and is very similar to the fundamentals of software architecture, but takes a different approach about describing software architecture. So look for that book as well. All right. Well, I'm anxious to launch into architectural thinking and what architectural thinking really is all about, because you, all of you listening, regardless of your role, can apply the techniques and concepts I'm going to show you in this talk to be able to see things from an architect's point of view. As a matter of fact, we might question what really is architectural thinking. Well, I suppose we can say it's kind of sitting back and, well, thinking about the architecture. But architectural thinking is much, much more than that. And I get excited about this topic because any of you can apply these techniques, regardless of your role or title, to be able to, well, see things from an architect's point of view, have better success at your products and your software developments. And so let me show you what architectural thinking really is. And in the context of this talk, we're going to see four things that software or that thinking about the architecture is. Architectural thinking, or thinking like an architect, is really about understanding the core business drivers and then how they translate to architectural concerns, things we call architectural characteristics. But it's also about other things. Thinking like an architect, seeing things from an architecture point of view is also about being able to see the structure of a system through the organization of the source code, being able to actually see and analyze the architecture. But thinking like an architect is also about having wide technical breadth. In other words, wide technical knowledge, but still maintaining a certain level of depth, that technical depth of knowing something really well. And then finally, thinking like an architect is about identifying, analyzing, and reconciling trade-offs. Now, I want to dive into all four of these sections because all four of these are necessary tools that you can apply on your daily job right away and be able to see things from an architecture point of view. So let's take a look at the first one, which is really understanding those business concerns and translating those to architecture concerns, things we call architectural characteristics. Now, this is the language of the business. When we talk about business needs or business concerns, the business is concerned about things like user satisfaction, competitive advantage, regulatory compliance, maybe heavy mergers and acquisitions. But our language in software architecture, kind of thinking like an architect, are all of these, well, what are sometimes called ilities of architecture, because a lot of them end in the word ility. But I like to term these architectural characteristics, things the architecture needs to support. And this is kind of our language that we have as architects. The problem is this, everyone. Well, we, during architectural thinking, are thinking about one thing in terms of those architectural characteristics. The business stakeholder is sometimes thinking about something else. And we get a lost in translation happening between these two things. So what I want to show you in this section is kind of how to think like an architect, how to use your brain as a translation engine to understand the architectural concerns from the business concerns. Now, one of the first starting points that most people hit is, well, I get it, I understand that, but how do I know which architecture characteristics, which ilities, or sometimes people call these NFRs, non-functional requirements, do I need for this particular system? The reason why these are so important is that these things we identify for our specific context form the foundation of our architecture, the foundation of that system, and also drive all of our architecture decisions. But they can come from one of three places. A lot of times they can come from simply the domain. In other words, we're going to build a new stock trading system without any other requirements. Knowing about that particular business domain, we can infer a lot of architectural characteristics. For example, the system's going to have to be fast, high performance, low latency, and high data integrity. But a lot of times, these characteristics come from requirements themselves. For example, we must support anywhere from 20 to 200,000 concurrent customers. But notice the requirement is not specifying, oh, we require elasticity. We still have to infer or interpret those requirements and match them to the right architectural styles, whether it be scalability or elasticity. But it's interesting. Most architectural characteristics, those things that the architecture must support, a lot of times come just from listening to the business. For example, we are aggressively expanding our business. Well, what in the world does that have to do with my architecture? Well, expanding our business means increased scalability, more customers. Maybe it's extensibility, adaptability, portability of our systems. So let's do a little exercise in this section right here, and let's see how this translation engine actually works. Before I start, I just want to let everybody know why these are so important. The functionality of your system, of your product, may be perfect. Oh, all the tests pass, it's flawless, except maybe it's not available, or maybe it won't scale, or maybe it's not fault tolerant. When errors occur, the whole thing crashes. Maybe it's not responsive enough. And these are the architectural concerns separate from the functionality of that system. So let's play a little game. So let's say that the business says, well, user satisfaction is the most important thing for us. We listen to the business, regardless of the functionality, and we take that business need, put it into our brain, that translation engine, think architecturally about that concern, and translate that to needs of the architecture. Things like performance, agility, the ability to respond quickly to change, security, availability, testability, fault tolerance. These are all things that contribute to user satisfaction. Notice the first observation. It is usually a one-to-many relationship. One business need usually translates to many architectural characteristics to satisfy that. Maybe it's time to market, or some people call this speed to market. In other words, we have to get our changes out faster than our competition, or we will lose our market share. Maybe it's bug fixes, new features, new products. So we put that time to market into our architectural thinking translation engine, and out of it comes maintainability, testability, and deployability. These are three things that allow us to have very fast time to market. Also, these three things really compose what is called agility, that ability to respond quickly to change. Well, maybe mergers and acquisitions is the primary concern of the business. And we put those into our translation engine. Pause. What do you think might be some of the characteristics that support mergers and acquisitions? So if you're watching this later and not live, pause the YouTube video and actually see if you could come up with that on your own, because this is what architectural thinking is all about. All right. Well, those of us live, let's take a look at it. Things like interoperability, standards, scalability. The more we acquire new companies, the more extensible our architectures need to be, the more scalable, because they will be handling larger user loads. Maybe it's about portability, openness. These are some of the characteristics that support those mergers and acquisitions. Now, this exercise is necessary because these architectural characteristics form the foundation of our systems, of our architecture. And each kind of architecture supports some of these characteristics, but some don't. So this star rating, 1 to 5 stars, came from our book, The Fundamentals of Software Architecture, where Neil and Ford and I analyzed all the various architectural styles against a lot of architecture characteristics. And this is where it comes into play. Let's say that scalability is the most important driver that we have in our system. We have to be able to scale to an increased user load. Well, we can see 1 star is bad, 5 stars is extremely well supported. And we can actually do what's called qualitative analysis to basically say, well, what supports scalability really well? And we can see 3 come out as 5 stars: microservices, event-driven, and space-based. This not only gives us guidance in terms of architectural alignment of our systems, but also gives us guidance in terms of if we are using, for example, a modular monolith that has 1 star. Chances are we won't be able to meet those scalability needs, even though the functionality is flawless. And so, another great example, maybe it's all about cost. We're a startup and simplicity and cost are the primary drivers. We have to get this system out, this product out as soon as possible because it's a heavy competitive market and we don't have a lot of money and we need something out fast. Well, you can kind of see, we look for 5 stars or a lot of stars, and we notice that, well, cost and simplicity. Now, cost 5 stars being good. It doesn't mean it costs a lot. It's good or bad. 5 stars is really good. 1 star is really bad. And we notice monolithic architecture styles give us that kind of characteristic. Whereas if we choose to do microservices, well, or service-oriented, or even space-based, we're talking 1 to 2 stars. Now, to help you identify characteristics, I have a couple of resources for you. I've provided the links right here, but this is a characteristic worksheet that I created, many, many years ago. This is what I use on my consulting engagements to be able to identify and validate those architectural characteristics. And you'll notice that we put the characteristics here in any order. I usually like to have collaborate with the stakeholders to select the top 3. Notice that we have some that are implied. In other words, cost and time, security, maintainability, observability. These are things we would always take into account. However, the way this works is if one of those implicit characteristics becomes a main driver, critical to the success of this system, not just we'll take care of it, then it moves into a driving characteristic. So you can look at one of my lessons that I have in Software Architecture Monday on my website at lesson 112, which kind of shows you how this worksheet works and kind of the dynamics of how to actually use it. So this is the first part of architectural thinking, is understanding what the architecture actually needs to support. And so this is really one of those first steps. Well, let's take a look at seeing the architecture. I mentioned the second part of architectural thinking was be able to see, observe the structure of a system by looking at the organization of the source code. And these are referred to as logical components. And so let me show you an example. So here is a floor plan of a very typical flat. Notice we've got a lot of different kinds of rooms and there's walls everywhere. So if we look at each of these, rooms, those rooms actually become, the building blocks of that particular house. And as a matter of fact, depending on the outside structure, which is kind of what we can maybe consider the external architecture, we can rearrange some of these rooms based on some partitions versus load-bearing walls. But by the same token, these rooms, maybe a kitchen, a bathroom, some bedrooms, a hallway, all make up that house. These are the building blocks. By the same token, the functionality, things that the system does, also form the building blocks of a system. And these building blocks all work together, maybe within a monolithic application, to say, what does this application do? Well, we have order shipment, we have order placement, order validation, or these building blocks may be put into services in a distributed architecture. You see, either way, the building blocks of a system, whether they're in a service or whether they're in a monolithic architecture, single deployment, form the building blocks of our system, forms what's called the logical architecture, which is independent of the physical architecture. These boxes you see here typically have source code associated with them. And these are the building blocks, things that the system does. Now, seeing the structure of the system is being able to identify these building blocks. And as a matter of fact, a lot of times we will take these building blocks, these logical components, and group them into various domains or subdomains. Now, we could actually observe what our architecture, what our structure of our product looks like by actually looking at the organization of the source code. Whether you're looking at a directory structure like here, or in Java, a package structure, which of course would match this. Maybe it's C#, where we're looking at a namespace. The point is that the higher level nodes in that namespace or directory structure represent a domain or a subdomain. And then the leaf nodes of our directory structure or namespace or package structures represent the architectural components. And let me show you what I mean. So let's take this ordering area here, and specifically, let's look at payment processing. This is a logical component. It's a building block of the architecture. Now, when we think about the logical architecture, what we're concerned about are things like how do each of these kind of components interact with each other? And that's what was known as coupling. But we're not looking at coupling between classes. We're looking at coupling between these building blocks, the size of these building blocks, the granularity of those building blocks. So here's an example. Here's a class file, creditcard.java. Notice it's in a particular package statement. This file, this source code, has to physically reside somewhere. So that somewhere, we choose to place it in the payment directory, because this has to do with payment processing. It makes sense. That's how we organize our source code. Well, it also turns out that the payment processing, as I showed you before, is manifested through that directory structure, payment, which means that creditcard.java, this class file, is actually implementing the payment processing component. And there might be dozens, could be hundreds of classes within that component. So this part of architectural thinking is really being able to analyze our structure of our code, being able to locate and identify the various building blocks, and also see how they relate. In other words, order placement may invoke a class file within payment processing. What that means is that these two components are coupled together. Payment, or maybe even returns and credit, may also do payment processing for be able to return something. And so now we start to discern the coupling at an architectural level, which may impact things like maintainability, testability, deployability, even scalability, especially if it's a distributed architecture, availability, fault tolerance, the list actually goes on. All right. Now, the third part of architectural thinking is being able to expand what's called your technical breadth of knowledge. Let me show you what I mean. So let's say that this triangle right here represents all of the technical knowledge in the world. And that's what you know, right at the very top, that little portion. And this is referred to as stuff you know. Um, for example, architecture, which I know really well. Maybe you know a particular language or platform extremely well to where you could actually do a Symphony TechTalk on it. This is the stuff we do every day. Really good at it. But then there's two other levels of knowledge. The second level is the stuff you know you don't know. And what I mean by that are technologies, platforms, languages, tools, products that you're familiar with, but you don't quite know how to use them. A good example might be the Clojure programming language. I'm sure all of you listening have probably heard of Clojure. It's Lisp-based. You gotta love parentheses if you're going to use Clojure. It has transactional memory, usually uses Datomic as its database. These are attributes, but if I were to ask you to code something in Clojure, you would say, oh, nope, never touched it before, but I know about it. That's a good example of the stuff you know you don't know. Now, the largest area of our triangle of knowledge is the stuff that you don't know you don't know. These are all the things you've never heard of before. And these things that you've never heard of before, you're completely unaware of them, may be the perfect solution to your problem, but you don't even know it exists. So the whole game of technology, careers, life, I guess, in general, is to take the stuff that you don't know, and you hear about it, and you start investigating it. And now you move that into the middle area of your knowledge triangle. This is like what your brain looks like. And then through something that piques your interest, or maybe your boss says the next day, oh, by the way, we're going to start using Clojure. Ooh, well, I know about it, but now I have to move that into the stuff I know, therefore increasing that area of knowledge. But there's a cautionary tale here, everyone. And that is this: be careful of the stuff you know, because that's the stuff that you have to maintain. And unless you don't have kids or don't have any friends or don't have any life and you love to work 24/7, then go wild. Maybe you've got insomnia and you like to work at night. Then you don't have to worry so much about it. But normally, yes, we need to maintain these things, because if you suddenly put something in that top part of your knowledge triangle and then just don't use it, it trickles down like sad little tears back into that middle area, the stuff you know you don't know. Okay, so what's the point of all this? The point of this triangle in architectural thinking is this: the stuff you know, all of us know something really well. This is what we do every day, is called technical depth, how deep we go into a particular area of technology. But the stuff you know, combined with the stuff you know you don't know, is considered technical breadth. And thinking like an architect, turns out, requires us to focus right here in the middle. In other words, it's more important, thinking like an architect, to know that there are 10 kinds of caching tools that support different kinds of caching topologies and the pros and cons of each of those, rather than knowing memcached extremely well or knowing Redis. Every solution will be Redis. Well, maybe it's not appropriate for our particular situation. And that's the reason why focusing on that middle area, the stuff you know you don't know, gives us the awareness of all the things that are out there, platforms, technologies, tools, products that we could apply to our particular problem. Now, let's go on a little journey, because I want to show you something interesting that happens in the progression of our careers. We're going to open up the brain of a typical technologist going through their career. So we start out usually as a junior developer, and then from there we move to a senior developer, like maybe a tech lead. And from there, we jump that little step over to a junior architect, and then we go all the way to a senior architect. Now, these are very generalized kind of titles or roles, but it's pretty typical in our industry. Well, let's actually look in the brain of how each of these kind of roles and persons think. Let's start with a junior developer. Now, notice as a junior developer, we observe a couple of things if we open up the brain of that junior developer. And that is, boy, the stuff you don't know is huge. In other words, I'm just starting out in this industry. Oh, have you heard of this? Nope. Have you heard of this? Nope. But the stuff we know is pretty big. I mean, languages and platforms and tools and stuff. But our technical breadth is also very short. As a matter of fact, if you observe here, you'll know technical breadth and depth are very close to each other. Okay, and this is fine. This is normal. This is what a junior developer's brain should actually look like. But now, are you ready? We're going to move over to a senior developer. Watch what happens in this animation to the brain. When we move to a senior developer, do you notice what happened? We increased significantly the stuff we know. Additional languages, additional databases, platforms, maybe API tooling, all these different things, we start amassing all of this expertise. That's what a senior developer does. But we haven't really increased our technical breadth much, because every time we find a new tool, a platform, that becomes another expertise that we have. And this is pretty typical and appropriate of a senior developer. Okay, now we're going to move over to a junior architect. When you cross over that line into becoming more of an architect, thinking like an architect, watch what happens. As we cross that line, did you notice a junior architect, we significantly increased our technical breadth, that middle area. But did you notice what happened at the sacrifice of the stuff we know? And as a matter of fact, I'm going to go backwards and I'm going to do that again. Watch the top area. So once we break over that line, it is more important as an architect to start focusing on that technical breadth, the stuff we know, we don't know, things we're aware of, different kinds of products and platforms and solutions and integrations that we can apply and learn more to see if it would actually be a fit. And we sacrifice some of that expertise. And then finally, as a senior architect, watch what happens here, is then we significantly increase our technical breadth, but not really sacrificing much more in terms of the stuff we know. And so if we kind of compare the software developer's brain, the way a software developer sees things and thinks, a software developer will see things and think in terms of the expertise that they know, the stuff you know. Whereas if we move over to a software architect, We notice, yeah, we're not an expert in all these kind of things anymore. We still maintain some level of technical depth. But now the way we think, the way we see problems, we also see a lot of solutions and possibilities, techniques, patterns, platforms, tools, all these things that we can apply to a problem. Now, let me finish this section by saying, well, that's great, but how do you do this? I mean, I'm a developer. I really would like to start thinking more like an architect. How can I do this? Well, part of the challenge of the stuff you don't know that you don't know is that you don't know it. So, three sources that I really like, InfoQ, and that's infoq.com. These are all free, by the way. D-Zone Ref Cards specifically, and also the ThoughtWorks Technology Radar. These are three sources I typically go to increase and maintain my technical breadth. And as a matter of fact, let me start with the ThoughtWorks Technology Radar, which comes out twice a year, provided the link there, thoughtworks.com/radar. This is a collection of, well, probably, in my humble opinion, some of the best brains in our industry come together and observe what the industry is adapting, what they're holding. And they put all these technologies, platforms, tools, techniques, all in a radar, things to adapt, things to assess, things to hold. And now we can use this as a guidance. In other words, all these luminaries in the field, James Lewis, Martin Fowler, Rebecca Parsons, Neil Ford, they have all done the work for us. And this is a great way. If you look at the radar, well, I'll guarantee you one thing. As you look at the radar, you'll see 20 things that are moving towards the center of the radar. We should adopt these. And I'll guarantee you, you've probably heard about 3 or 4 of those. It's a very humbling experience, but a way of being able to find out stuff we don't know we don't know. The DSON ref cards are useful because these give a short synopsis of a particular platform, a language, a tool, a technology, just enough, 2 to 5 pages, sometimes 6, where we could find out what something is about without having to really learn about it. And then my favorite is InfoQ. I sign up to InfoQ, it's free, and every 2 to 3 days, I get an email, as a matter of fact, and this is what my email looks like. And if I zoom in on this, you could start to see what the format of this email looks like. So across the top, you'll see a lot of buzzwords, and you can certainly click on these, or if you don't feel safe clicking on email, which is probably a wise thing, you can go to infoq.com and see each of these. But this is a great way of all of a sudden saying, wait a minute, Dagger. Does anybody listening know what Dagger is? If you don't, that's a really good example of something that you don't know, maybe it's Penora. Maybe it's something like DuckDB. That's kind of interesting. Another kind of database. Maybe it's GlassCube. Okay, that's probably something to do with Kubernetes, but I wonder what. These are all great ways of seeing something, a word, and saying, I have no idea what that is. That's a good representative example of the stuff you don't know that you don't know. Click on it. Just Google it. Spend a couple of minutes and say, oh, I get it. So that's a kind of an in-memory analytics database. That might be coming in handy. Or you might say, oh, yet another web framework and be very disappointed. But this is a great way. Listening to conversations and somebody says something about blah, 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 Blaze. Like, oh, I wonder what that is. Well, you might say, Mark, we're all busy. I wish I had as much time as you to kind of just sit back and do all this reading. Well, truth be told, I don't either. So what I do is something called the 20-minute rule. I spend 20 minutes a day on me, on my career, going through any of these sources, or maybe you have another favorite one that you go to. Maybe spending the time to just kind of generally collect some buzzwords you don't know, maybe spending 5 or 10 minutes on each of them. But 20 minutes a day or more, but at least a minimum of 20 minutes. Now, a lot of times the day escapes us. I used to do this at lunch. Ha ha ha. Laugh, laugh, laugh. How many of us actually get to eat lunch? I do this in the morning. Ah, but there's a time. So, what do you do when you first wake up and go to work? Now, I'll answer that, whether it's remote or in person work. You grab that blessed cup of coffee. Yes. What is the very next thing you do? Check email. And when you check email, everybody, your day is over. You get caught up in the vortex of emails, and all of a sudden you see that there was an outage, and your day's pretty much over. So after that blessed cup of coffee or tea, before checking email, I spend at least 20 minutes obtaining that technical breadth, allowing me to think more like an architect. All right, one last section before we close here, because I know we're running quickly out of time, but we're doing good on this. One other aspect of thinking like an architect, seeing things with an architecture perspective, is about analyzing trade-offs. In our first book, The Fundamentals of Software Architecture, Neil Ford and I coined the first law of software architecture, that everything in software architecture is a trade-off. You can't say I should always focus on performance. No, we don't need performance in our system. We need high data integrity. We don't care about performance. Everything is a trade-off. Now, what that implies in the structural aspect of software architecture, that there's no best practice. A best practice is where you can turn off your brain and just blindly choose an option. It doesn't exist in the structural part of building a system. So then in our second book, Architecture, the Hard Parts, we asked the question, well, then what happens if there are no best practices? I mean, we live off of best practices. I don't know where to start. I mean, I use best practices as a starting point. Like, where should we start? Well, what are the best practices? None. It's like, oh dear. So in this case, let me show you modern trade-off analysis. Not surprisingly, it starts where this whole talk started, right at the business drivers. Understanding the needs and concerns and goals of the business. For example, time to market. Oh, we saw that we translate those business needs into architectural characteristics. Now we can apply things. So we have a decision. Should we keep the service together, or should we break it apart? That is an architectural decision. We're changing the structure, the physical structure of our system. Well, I don't know. How can I actually ask that question or answer it? So what we do is this, everyone. We analyze the trade-offs and boil it down to the bottom line. You see, a bigger service, keeping all that functionality in the same service, gives us much better performance because we don't have to talk to other services. But if we separate them, it gives me much better maintainability because I can go to a single deployment unit. I know exactly where to change it. My testing scope is smaller. I get better completeness of testing, a lower deployment risk, smaller deployment module. Yeah, much better maintainability. Well, how do I make that choice? What I do is I tie it back to the architectural characteristics, and we see maintainability is actually on the list of things the architecture needs to support. Oh, we tie it back to the business and say, which of these two, performance or maintainability, will satisfy our concerns of the business? And that happens to be time to market, which actually has nothing to do with the performance of our system, meaning maintainability is more important. That's how we apply trade-off analysis. So let me close by actually showing you an example, because a lot of times we say, well, that's great, but we don't have any existing systems. In other words, I'm not sure which architecture style to use for my distributed architecture. Event-driven, service-based, space-based, microservices, I just don't know. Well, let's actually wrap all this up by showing you an example, all of these things together. So we see, based on our breadth of knowledge, that each of these architecture styles have various star ratings. And as a matter of fact, have superpowers. These are the 5 stars. And every architecture has their superpowers, but also their kryptonite as well. Well, that's good information, but don't fall into that trap, because it seems like microservices is great. But what was our concern? Our concern was time to market, which translates into maintainability, testability, deployability. That's our context. So I come back to those star ratings and focus it just on those things that are important to me. And I can use what's called qualitative analysis to be able to say, let's see, 5 stars. If I go to service-based, it's 4, event-driven 3, and space-based 2. So the quality comparison between these looks like microservices might be the best fit. But then, everyone, once we start developing something, we have to apply what's called quantitative analysis. Once we have something in place, now we can measure it to get exactly what that difference is between the stars, because we see 4 stars and 3 stars. Well, what's that difference? Don't know. And now we apply something called fitness functions to be able to actually measure our overall agility. And in fact, we can now quantify that difference and see that, in fact, we are moving faster. And as a matter of fact, we are producing fewer and fewer bugs. And so all 4 of these together really are what comprise what are called architectural thinking that you can apply to your daily activities, regardless of your role, to start becoming more efficient and more effective in your software architecture solutions. So that is the presentation piece, but I'd love to address any questions that you may have. So I am ready for questions. I'm assuming there's probably some, but
There are.
awesome.
Yeah, okay. Well, first of all, thank you so much for the presentation, Mark. And there's a lot of resources that we can find information about you, which I probably did before the talk started. So I enjoyed every other talk that you gave, every other speech, everything that's available on YouTube. And now we are happy to have you on the Symphony TechTalk. So yes, I'm thrilled to announce, by the way, that we have people watching us all the way from Netherlands, Macedonia, Egypt, Nigeria, Italy, all over Ukraine, Warsaw, Argentina, Toronto is here, India, South Africa, and the UK, and so many more. Um, and here are a couple of questions that have been asked already in comments. You can actually see them in chat. So this first one here was from, I believe, Martin, and it was, can one architecture be used for transition for resolving the business driver for solving technical debt, but later be adopted into another, i.e. model-based transition to microservice target?
Yes, and the answer, fortunately, is yes. There's a lot of transition paths within a lot of the architectural styles that we have available to us. One of the most popular of those transitions is, well, we're not sure whether we really need microservices, want microservices, and it's very expensive and very complex, and it's hard to set up the environment, but we don't know if we'll need that. So one of the paths to do that kind of transition is possibly to start out what's known as a modular monolith. Now, this is a single deployment unit. So it's a monolithic application, but the functionality is divided or delineated into domains. And then once we see the need for increased scalability, maybe increased fault tolerance, maybe increased performance, we take each of those domains and we move that modular monolith into something called service-based architecture. Service-based architecture is a distributed architecture that has an application or a system context where each separate deployment unit, each service, is a domain. So all of that functionality in that particular domain gets carried over into a separately deployed service. And this maps very well because each domain within a modular monolith can be extracted and put into a separately deployed service. Then, where needed, we take each of those domain services that we need additional maybe testability or maintainability, that's overall agility, maybe it's scalability, elasticity, fault tolerance. And then we take that domain service and we make it into microservices. So you can see what we start to form are hybrid architectures. That's one very typical pathway, Martin. Another one might be to start with service-based architecture. And the reason I like this path so much, Martin, is that not every portion of an application has to be microservices. We see a lot of things like the headlines last year about Amazon Prime moving, quote, back to a monolith. No, Amazon Prime did not move back to a monolith. They made more coarse-grained services. And this is a fairly common, trap, I'll say, to get into, where we start out too coarse-grained and we realize we're not getting many benefits from this. Let's bring all that functionality back together into a more coarse-grained, domain-based service. So my preference is to not go all the way over to microservices and then retreat, but rather move forward in a controlled, iterative manner. So that's one great example of that transition you're talking about, Martin. Yeah.
Okay, thank you very much. And now I think I can share my screen with you and just to actually show you how many questions we
Oh,
have.
wow.
Yeah, so this next one was from Valentin Cherkaso, and it says, what should I do if my vision as a programmer does not coincide with the vision of the business?
Wow. So, boy, it's so funny. We could probably do another 45-minute session just on that one question. A lot of times, that misalignment comes from the lack of collaboration and the lack of understanding from both parties, from a developer not really understanding what the business needs. A lot of times this happens from programmers, developers, not having access to key business stakeholders. A lot of times we rely on our product owner. But a lot of times this happens because developers, software developers, are in the trenches. We're developing the actual user interfaces and the code, and we have additional insights that the business doesn't have. And so consequently, we get out of alignment. And so when we talk about collaboration, it's not only for developers to understand the business needs and the business agenda, but it's also to collaborate to enlighten and also to educate the business on restrictions, constraints, trade-offs. As a matter of fact, I'm going to bring this back to architectural thinking because a lot of times we as architects, our job in architectural thinking, so I'm not even going to say an architect, our job as a technologist, when we apply architectural thinking, is to come up with what are the trade-offs for a particular decision or approach. Now, a lot of times we can't make that decision, but our job is to bring that trade-off to the business stakeholders, to our product partners, our product owner, because a lot of times, and this has happened to me a lot in the past 38 years of working, a product partner, product owner, business stakeholder will make a decision, but they make that decision not understanding the implications, the trade-offs of that. If we as architects or we as technologists apply architectural thinking, well, we can now collaborate with that business stakeholder and say, I understand this is the approach you want to take. What I'd like to do is show you the implications and the trade-offs associated with doing that approach or implementing this kind of functionality here instead of over here. And in so many cases, it's simply that the business stakeholder or product owner did not understand any trade-off associated with their decision. So it's all about collaboration is the bottom line. And that's the reason why these things occur. And in fact, it does a lot. So this is one approach to take to really try to collaborate more to educate the business in terms of the implications and trade-offs and to work together. Collaboration is really working together on a solution as opposed to what we usually have, which is communication. A decision is made from on high, communicated to us. We disagree and we communicate our disagreement back to them. That is not collaboration. So yeah.
All right. Well, thanks, Valentin, for the question. Well, let me share the screen with you once again because I really want you to know how happy our audience is about you being our speaker
Oh, that's
today.
great.
And yes, everyone's loving your presentation. They are actually asking if the presentation will be available. So if you share that one, we can actually send it out to all who registered for the event.
Mhm.
Okay, they
Go
are
ahead.
checking the Dear Architect weekly
Oh,
newsletter
yes.
and the Bike by Go.
Great resources.
And yes, we have listeners from Iraq. And here's another question from Makola. Thank you very much, Mark, for the presentation. It says, considering your background in astronomy, do you think there is an extraterrestrial life? And if so, do you think it could learn Java?
Well, in answer to the first part of the question, yes, I do. Having been an observational astronomer for 3 years, I studied the heavens. Specifically, I was in charge of at the observatory of looking for black holes, variable stars, and binary star systems. But as you're gazing out into the stars, like you can see behind me here, it's hard to accept that we are the only ones out there. So yes, I do agree that. Regarding Java, I really hope not. I would hope not, because that's going to be a very big impediment of any sort of progress of any extraterrestrial life. No, I still code in Java, but I just got a kick out of that last part because I feel like there's so much more advancement we can do, and we're seeing that with AI and such. In infiltrating within development, starting to infiltrate a little bit within architecture, but there's reasons why it won't fully infiltrate. So for all of you listening, it's my humble opinion that one safe area right now to avoid the AI trap of being replaced is, in fact, software architecture. Because AI has knowledge, but software architecture requires wisdom. It's all about trade-offs. There are no best practices that you can apply. It's all about context. And so this is a safe place to be. So yet another reason to embrace architectural thinking and look to that area of a career path.
Okay, thank you very much for another great answer. And we still have a few questions, and we actually have a few more people waiting to ask their questions live. They've earned it. So this next question is from Lara. Do I need much experience in backend development to actually think architecturally? What do you think of that?
Um, so can you repeat the question again?
It says, do I need much experience in backend development to be architectural thinker?
Oh, yeah. So, I would say some knowledge, yes. And the reason when we start to apply architecture, it really does kind of span the whole gamut of user interface, functionality, APIs, gateways, integrations, databases, which makes it one of the hard parts about being a software architect. Now, that said, you don't have to be an expert in these areas. I like to use the phrase standing on the shoulders of giants. In other words, as an effective architect, I may be able to rely on some of my senior developers and tech leads within the user interface space to work with, to collaborate with on certain assumptions, designs. That doesn't mean I, Mark Richards, as a architect, have to be an expert in all of these things. Familiarity, being aware of these things and having some level of experience is really, really helpful. So much of it depends on what sort of resources and team structures you have to rely on those teams. This is a great question because I can't help but go on a little tangent here about this. All too often, software architects believe and think that they have to be an expert in the entire stack in that company in order to form an appropriate solution. And I have thought that at times as well. Well, listen, unless you're a real superstar, it's really not feasible. And so, better to understand that technical breadth, but then collaborate and rely on your development teams, rely on other architects with different expertise to be able to collaborate to form a solution. I may not be aware of some of the limitations within the latest version of Angular. And I may make some certain structural assumptions that that particular framework doesn't fit well in. And if I'm collaborating with some user interface or UI developers who understand that, we're going to come up with an extremely good solution. And so it's good to have that familiarity, certainly, but please don't think that you have to wait to become an architect until you have expertise in all these areas. So much of it is collaboration and those soft skills of working together to get solutions, solid solutions out the door.
Okay, thank you. And Mark, do we still have at least 2 or 3 minutes of your time because we still
Sure.
have a lot of questions? Okay,
Oh,
thank you
yeah.
very
I
much.
love questions.
Okay, so I'm bringing in this another participant to actually ask question live. Like I told you, he earned it, and that's Alexander Falinets. He's an active participant of all of our virtual communities and a great architect and a great symphonian. So Alexander, please proceed with your question. Go ahead. We can't hear you, man.
Thank
Okay.
you. Yeah.
That's never happened before, by the way.
Yeah. Thanks a lot for a great presentation. It's super cool as always. Actually, I've got even a lot of questions you already answered during the speech, but I have like around 3 questions. So Bogdan, please stop me in case we are running out of time.
Okay, I'm stopping you right now.
Oh.
Okay,
Uh,
let's do one.
Okay, I think it's the most common questions usually I hear, and we have similar questions in the chat. Meanwhile, I've analyzed it. Actually, could you provide some recommendations how to start and become a junior architect? Yeah, we need to invest in our knowledge, the stuff we don't know, start and subscribe to InfoQ, TechRadar, and so on. Maybe anything else might be useful for them, like some practical exercises, some other resources, I don't know. Test tasks for becoming junior architect. So any of that?
Yeah, that's it's a great question and a very common question as well, because the problem is, and this is one of the drivers, by the way, for our Fundamentals of Software Architecture book, was this is a multidisciplinary field, software architecture, that doesn't have a clear career path. It's really hard to know where to actually get started. So let me answer your question for you. One of the first things to start that transition into saying, I kind of really want to be a software architect. And I always answer the question, then start thinking and acting like an architect. In other words, some of the stuff I did in this talk, for example, that I showed in this talk, starting to increase your technical breadth of knowledge is one key skill to that anybody listening can actually start on actually today. It's still only 20 minutes, but also it's half of being an effective software architect is really those people skills, the soft skills we call them. Being able to be that go-to person on the team. You may not necessarily have all the answers, but you can help find those answers. And being able to understand how to collaborate and to negotiate and talk to people, that is a hard skill to learn. And my advice on that skill is just do it. The number of mistakes that I have made in soft skills would take at least a 4-day class to describe. That's how many there were. But learning from those mistakes made me more effective in knowing what not to do and kind of what to do. Also, understanding the quote language of architecture, architectural styles, different architectural patterns, really getting a sense of what do you mean when you say architecture? Like I showed you an example, it's the structure of a system, but outside of that, in the physical architecture, it's how services communicate, the different databases, the services, the API layers, the user interfaces, integrations to other systems. It's the structure. And starting to become more familiar with that structure is another good place to start. Now, we're going to finish the question by my favorite way to start. And that is, I showed you some tools here today in terms of architectural characteristics, understanding the business needs. I'm encouraging everybody listening to this, please do that. Try it out. Download that worksheet, modify it any which way you want to, and say, what does this architecture need to support? Trust me, it will make you a more effective and better developer. You will have awareness of what the architecture, not the functionality, but the architecture needs to support. You can start to measure these with fitness functions. These are tests that we write with code to see, are we really scaling? And this, by the way, is acting the role of an architect. And doing these practices will start melding you into that role. People, bosses will notice that you're taking charge. You're understanding the bigger picture of our system here and possibly finding some deficiencies that were hidden. And so these are all kind of the answers. I will tell you that on my website, developer2architect.com, and that's a TO, developer TO architect, I do something called Software Architecture Monday, which every 2 weeks I do a 10-minute video in YouTube. This is all free. You don't register. It's just all free. Well, lesson 86 starts a 6-lesson journey on becoming a software architect. It's just 6-10-minute videos that show you kind of a pathway. It charts a course in the journey to becoming a software architect. So that would be another great resource as well. Yep.
Thank you very much. Thanks,
Thanks.
Alex, for coming in, and thank you for your questions, and thank you for your patience, man. I'll talk to you later, okay? And Mark, I have another question for you, and this probably will be the last one in this questions and answers box, but that's from someone who is now a QA automation lead. And so the question is, I wanted to ask, as a QA automation lead, I have another level that I would like to reach, which is architectural level. What do you think separates a senior QA automation engineer from an architect? And what do you recommend as a path to get there according to you? Thanks again.
So certainly, a QA automation lead is one aspect of the whole life cycle of developing software. I think that any of those kind of roles can, in fact, transition into software architecture. In other words, here's a really great example. In today's world, there's a big shift over to distributed architectures, namely microservices. This requires a bridging, a changing of team topologies, where unlike our traditional monolithic n-tiered layered architectures or modular monoliths that we traditionally build, that we, quote, hand off to a QA automation tester, or that the QA automation tester decides, how am I going to test this? These roles start becoming more collaborative on the same team. So one way that you can start converting your skill set as a QA automation lead into architecture is start also testing the architecture. So as a QA automation, I imagine that you are inundated with a lot of testing functionality, scenarios, making sure that the system or the product is correct. Take that one step further and embrace something called fitness functions. This has been described in our book, Hard Parts, as well as Neil Ford's book, Building Evolutionary Architecture. But a fitness function is a test that we write based on observability. So these are tests. It's a way of saying, I'm testing and automating the functionality tests, but I'm also going to go the next level, and I'm going to start testing the architecture. I'm going to start testing the things that are critical, hence that worksheet I showed you. Scalability, I'm going to test our responsiveness. I'm going to test our fault tolerance, our agility. Maybe it's our testability itself. And by doing that, now you are involved in the architecture. You're understanding the architecture of a system a lot better. And so that would be my very first recommendation, above all the other things that I've talked about in this talk, would be to start testing the architecture as well. And that is all automated. And so it fits nicely with your role.
Thank you very much, Mark. And just if I may, I have another great engineer as well as an outstanding symphonian here, Stas Krakowski. He's been promoting this event all the way internally. So Stas, this would be the last question for today. I am so sorry we can't address any more. Stas, please check your microphone because we can't hear you. And now you may ask your question. Go ahead.
Right, Stas.
Yeah. Hi, Mark. Hi, everybody. Yeah, it's great. I didn't want to be the last one, but okay. So first of all, I have to do this. So yeah, I'm watching. I have been watching developer software architecture Monday.
Oh yes.
For the last 5 years, I would say, maybe less, maybe. Okay, never mind. But I watched every, and I would say one time I watched the episode about the cup theorem, and
oh yes.
at the same time I had an interview, and I had a question about the cup theorem. So half of the interview, I was telling them about the cup theorem, exactly what I just watched in the your
Oh, that's
video.
great.
So yeah, guys, everybody who are here, please subscribe to Software Architecture Monday every 2 weeks. Yeah, or yeah,
Yep, every 2 weeks.
every
Yeah.
2 weeks. 10 minutes, and this is really great. And my question is very short. You just taught about the fitness functions, yeah, and it's supposed to be actually a test,
Mhm.
different kind of test, yeah. But we always, my question is not that smart as fitness functions. We hear about architects. Okay, architects is someone who, of course, knows how to code.
Mhm.
So if you have an architect, we suppose that 100% of his time he will code, and another 100% he will be an architect. And when we tell, okay, architect is not supposed to code, everybody, how? He is the smartest one. Yeah, because he is an architect. No, he is not the smartest one. But at the same time, the question is, what could you suggest? How much, how many time, how many hours, yeah, how much time an architect should actually code in the project?
Interesting. What an interesting question, because I do concur, I do agree that architects should still write software, should still code. It's going to vary so much based on the type of coding we can do, the opportunities to code, and when we get into a tough spot where I am needed as an architect to resolve conflicts, to maybe resolve design problems, to resolve an architecture problem, maybe we're stuck on a migration, and that's going to take 100% of my time. So I guess the answer would be enough to where you're still able to keep your skill. And you're right, fitness functions are a great opportunity to be able to write code. Not only custom code for operational concerns, but I showed you the structural part of the system, those logical components. Tools like ArcUnit, ArcUnit.net, NetArcTest, Python now has a PyArcTest for Python. These are tools for free that you can actually write your architecture decisions for compliance. These are great opportunities to write code. Another opportunity to write code is when you're faced with a decision. I could choose option A or option B. I don't know. So one of the things I will do is implement both. This is going to require me to code. And a lot of great things happen. First of all, I get practice coding. But number two, with these two decisions in place and everything looks equal, I can actually see the implementation concerns. If I start coding it and saying, oh, I'm glad I did a POC on this because this would match our infrastructure much better than this option. But another tip about that, though, because I do a lot of POC kind of coding. As an architect, I will develop a POC and everybody loves it. And then it goes into the Git repo and it starts getting leveraged. It becomes part of the architecture. It becomes the reference architecture. So this, everyone, is a great way to, if you are going to just sit at work or home and you know you're just going to delete the code, like literally delete the code, you're not going to show the code to anybody else, then write as sloppy code as you can. But if you're going to show it to people, if it's going to go in a Git repo, my advice is to write the best possible production-ready code you can. There's two reasons. One is it gives you practice in writing very good production quality code as opposed to hacks. But number two, if you hack something together and it's in the Git repo as the reference architecture with your name on it, do you really want that to be the representative example of the way you code as an architect? And the answer is no. So this is another great way to actually be able to code. So there are plenty of opportunities that do exist in writing tools, anything to automate. We talked about the QA automation just on the last question. Anything I can do to help my team by automating some tasks, I will write those CLIs, those command line interfaces, just to crank out a tool. These are lots of opportunities to code. So I would say just enough to where you are still able to sit down next to somebody, mentor them, help out with an extremely hard problem. It's like, I'm stuck here. Okay, step aside. Let's sit together and let's figure this out. Or we're at the 11th hour on an extremely important iteration, and somebody calls out sick. I should be able to step in and take over for them to get that iteration done. It's a great way of gaining respect and being able to mentor team members as well. So yeah, there's a lot of great reasons why we should code. Some people just maybe only need to code a couple hours a week to be able to maintain that. Some people may need to do 10 hours a week to maintain their coding skills. Some can wait 3 weeks and just hop right in and just start coding away like they were coding yesterday. So it does vary, I think, and depend. But yeah, it's a great question. When we talk about architecture, please don't think that you have to abandon coding. No, most architects I know still code. I still code, and it gives us all those benefits I just described to you. So yeah, great question, Stas.
Thank you, Stas, and thank you very much, Mark, for all of the answers. I think we are so much done for today.
Yeah, that's great.
So like, but there's been so many more questions. We can't address them right now. You are welcome to check them out after we're done with the talk. However, I really want to say a huge thank you for agreeing to actually speak for us. This was Symphony TechTalk, and we were talking to the legend, Mark Richards. We were talking about how to get ahead in tech with architectural thinking. We appreciate every single minute of your time. Thank you for being with us. Thank you for your support. And all of you out there, please subscribe to this YouTube channel of Symphony Solutions. There's a lot more Tech Talks ahead, and please subscribe to all of the resources that Mark has advised you to do, and try to reach out to him on LinkedIn or anywhere you actually can. We're done for today. It was an incredible Tech Talk. Thank you so much, Mark.
All right, and thank you so much for having me at your Symphony Tech Talk. Thanks so much.
Yeah. All right. Take care, all of you. Bye-bye.